Hello there, I'm Roger Webb and welcome to my workshop. Today we're going to continue with the MIDI CNC rotor build, which incidentally all the drawings and specifications and parts list is available on my Patron pages. So today we're going to make these brackets which mount these large NEMA 17 stepper motors, okay, which is going to drive the little CNC rotor. The previous video I used Carveco Maker Plus and showed you how to use it as a CAD-CAM system to make something like this bracket. I'm going to run the G-codes in my little converted X2 SIG CNC mill. Again, I made some 15 videos on everything that I did to convert this standard mill to a CNC mill. And sometime before Christmas, hopefully, I am going to have all the drawings, specifications up on Patron of this build kit. Okay, so you can go and have a look at the videos, and if you want to build one and use my drawings and specifications of how I built this, you can sort of match up the drawings and everything else with the videos and see everything that I did to convert this into a very, very useful, pretty inexpensive CNC mill. And I use it all the time. Actually, we're going to cut this pocket first. So I'm going to load the code up for this. So go to File, Load G-code, and there it is there. You see it appears here. So now we'll put our part into the vise and set it up. Now I'm using a very simple workholding method for this little bracket. Now it's going to be difficult to hold in here because this is above this height and I don't want to just grip on the back edge here because this will flex, so you've got to stop it from flexing, but at the same time I need to grip it on this, so I just use a couple of pieces of hardwood that's the right length, okay, and then I use the end grain of this piece of wood to be able to grip onto that face there, transferring the load from this jaw. So and I've preset this up with the 00 because I'm doing multiple parts, and you can get this within a couple of thou, and do a bracket or something like this. You know, it's a fairly easy process to do, and I just use something of a known value like this. Let's get a fresh piece of material, shall we? Okay, here's a nice fresh one. So you can see now that I'm going to be gripping this face, but I'm using this block of wood to actually transfer the load. It's as simple as that. I'm doing these simple sort of jobs. You know, I've only got 4 of them to make. And providing they're within a you know, sort of 5 thou or so, it's fine to use something like this. And then we'll just squeeze it up there. Okay. Now we need to get it a little bit tighter than that. So we'll just put quite a bit of pressure on this now. Okay. So that'll be fine. That's pretty firm there. Now I'm going to be using flood coolant for this because this is aluminium, and you can cut it dry but and use something like WD-40, but you know, I've got flood coolant set up on this little mill, so that's what we're going to use. But I'm going to have to close the door. I don't want to get the camera wet. Okay, I'll just show you a couple of little things with Mach 3 now. So I put in the next code, which is a drilling strategy, which is to drill these 4 holes very accurately around this pocket. And you'll see there's just a graph representation here. And this is the G code. So what we're going to do now is change a tool, because it's a different height, or going to be a different height above the work. So the first thing we do is fetch out the built-in MPG, because what we're going to do here is we're going to change this figure here. Now this is the jog rate. Now we're going to put it up quite a bit. Now you can either type in the number, the percentage you want there, or you can just simply take it up like this. Now that's okay for us. So to make this fly out and to lose it again or take it off the screen, you just press tab. Now to raise the Z up and down, that's the column, press the page up. It's as simple as that. I do have a external MPG as well, which I would normally use, but not everybody has those. So now we're going to change this tool. Now on this particular machine, it's just simple locking mechanism to lock the spindle, which is through here. There's just like a keyway machined. There we go, just clicked in now, and that's locked. So you get a key and undo. It'll go so far, then you've got to put the key on again and undo even further. Now that one will come out. So that is a 2-flute 6mm, which you know, either a 2-flute or a 3-flute I recommend for aluminium. Very good. This is a carbide end mill. Okay, for this next drilling operation I'm going to use a center drill. So a center drill has like 2 drilling ends, as it were. It's got like a pilot drill and slightly bigger, because I just need this to put a 3mm deep hole in there, so then I can actually drill externally from this machine. Okay, so this just gets screwed in here. Take it up as far as you can with your hand first, and then tighten the collet up. This is a collet chuck, an ER32 collet. Okay, it's nice and firm now. Okay, I'm just going to bring the tool down very close to the work now. I'm now going to change the jog speed, which is the exact opposite to what we did to raise it up. It's very quiet. Now what I'm going to do is tell Mach 3 essentially where the end of that tool is in the relation to the top of the material, and to do that we just simply use a piece of paper. This is the most inexpensive method. You just put a piece of paper underneath the tool and just move it slightly when the tool gets close to the material, and you just jog it down until you just trap that piece of paper. And I'm just pressing the page down button. Just trapped it there, only just. So now I can zero the Z. Now at present I have loaded up the new code, and here's the trace of that code, and I can push up, down button, left, right, nothing is working at all. And the reason being is because the reset is flashing. It's in emergency mode, so it's necessary for Mach 3 to operate the CNC machine to press that. It goes all green. Now it works. And we're going to run this program without flood coolant. It's okay, it'll drill this in aluminium. The aluminium will dissipate any sort of heat, and you know, it's absolutely no problem at all. Change out the other 2 units, and we'll just do the same job. So what I'm actually doing here is I'm making a flat area here, so the head of this retaining screw can be flat against the material there. And of course this hole is just a relieving hole, so I can actually get this screw in and out. Okay, so there's our finished bracket. And of course the motor fits in here like this. I'll just pop these screws in. And of course that's what those larger holes are for, if you can see that. So you can easily get an Allen screw on there. And I just want to show you something as well. Let me just undo that one a bit. Alright, so I'm not doing these up tight at all. I just want to show you something. I'll come a little closer. Now, these screws are 3mm or 1/8 of an inch, the right size thread to fit into this boss. But if you notice, I can move this. I have a millimeter. If you notice it, I can move this. Okay. This, in engineering terms, is called wiggle room. Okay, this is exactly what wiggle room is. It allows you to have some adjustment, some minor adjustment to line a shaft up, you know, very, very sort of accurately. And when you're dealing with, well, low sort of energy torques and things like that, such as a little CNC router, this is fine. And this is the way that you achieve it. To get your, you know, to get your tolerances absolutely right, there's a certain amount of wiggle room required. Okay, and of course, this is where this attaches to. In this case, this is the Z-axis, and there will be a flexible coupling in between here, and exactly the same bracket and motor arrangement will go here for the Z-axis. So I'm making this MIDI CNC as modular as I can make it. When I say modular, I mean that the Y-axis and the X-axis are identical, and in actual fact you can swap this around. The only difference is the mounting holes here. That's the only difference. The makeup of the axes are identical. Makeup of the mounting mechanism for the stepper motors are identical, so it's modular. In other words, it doesn't matter whether this motor and bracket fits here on the Y or the X or the Z, identical, so that everything's interchangeable. And you know, I've made it this way purposely because when you're setting up to, you know, sort of put the rails on or cut the material, everything's identical, and it makes it a lot easier. Okay, I will add to that, the only thing that is custom made is the X-axis, because it's actually condensed. It's a lot smaller. Not an awful lot smaller, but a bit. Okay, so I think that'll do for this little video, and my next job on this is to make the, I have some reducers to make, just metal reducers to fit on here to fit my flexible couplings, because they sent me the wrong size. But that's okay, that's just a small job, and I'll probably do that on my little CNC converted lathe. And incidentally, my little CNC mill that you see me make these brackets on, now that's a conversion that I designed and did a full conversion on. I made some 15 or 16 videos. They're in a playlist on my YouTube channel, if you'd like to go and have a look if you're interested. and also I plan to have all the drawings, specifications, and all the units that I bought, you know, the motors, the drivers, everything that I put into that machine will be on Patron, as well as the plans. It's a conversion that you know, I designed myself, if at all you're interested in doing the same. That machine was originally a SIG X2. Now they're widely available. They're available under different sellers' names like Grizzly or Harbour Freight. I think they still deal with those, but you know, they're widely available. Okay, so I think that'll do it for this video. Please like and subscribe, and if you would like to pop along to my Patreon channel, and if you would like to become a patron, that would be a great help to the channel, because it's the patrons behind the channel that keeps it all going and enables me to do things like this for you guys. So thank you for joining me, and it's bye for now.